Good afternoon. Today we are going to talk about the circular motion and what is the meaning of the uniform circular motion. And there are some words, the keywords that we need to understand this lesson better. What are the keywords? The uniform circular motion is the first one, and the tangent velocity or speed. We will talk about what are the differences between the speed and the velocity, and we will talk about the centripetal acceleration, centripetal force, and we will talk about the inertia. And while explaining these keywords, we will use our PowerPoint. Then we will have an experiment about the garden hose experiment to understand this lesson better. What is the meaning of that? We will use simply this garden hose, and we have a ball, and we will see the inertia, and we will see the centripetal acceleration, velocity, and the centripetal force by using this experiment. Let's get started. First of all, what is the meaning of the circular motion, and in our daily life, what are the examples for the circular motion? As you can imagine, this should be a circle, like a sphere, like a zero or a spherical shape. There should be these movements. For example, a car traveling around a circular ramp on a highway, or a ball tied to a string being swung in a circle, or a cowboy is using a string in order to catch a cow. In Texas, we can see this kind of examples also. And the other example, the moon is turning around the earth, revolving or make a revolution around the earth. Or the earth itself is turning around the sun. These are the examples of the circular motion. Okay. And also we can say the electrons are turning around the atom, the nucleus. So this is another example of the circular motion. For example, if you go to a circus, you can see a motorcycle is turning around a circle without falling down. With using the speed and the velocity, it's turning around a circle and it's not falling down. This is another example of the circular motion. And in this case, let's start with the uniform circular motion. The uniform circular motion is starting with the uniform. What is the meaning of the uniform? Uniform means the not changing anything. Let's say uniform means the constant. Uniform circular motion means the motion which is inside of the circle, but the speed or the velocity is not changing. It will be fixed. Okay, this is the motion of an object in a circle at a constant speed. We are not using, in this case, velocity. We are using speed. So there are two words which is very close to each other. About the meaning, but they don't have the same meaning, the speed and the velocity. What are the differences between them? For example, 40 kilometers per hour is the speed. As you can see, there is a magnitude 40 and there is a unit, kilometer per hour. This is the speed. If we add one more information, which is the direction, east, okay, this is gonna be velocity. So velocity is speed plus the direction. Okay. If we talk about 40 kilometers per hour to east, to center of the circle, or any direction, is gonna be the velocity. Okay, this is the difference. What is the meaning of the tangent velocity? Tangent velocity, and tangent means at the outer side, outer part of the circle. And here we have, in this path, in this circle, there are different velocities. Why? Because they have different directions. Okay. Maybe they have the same magnitude, they have the same speed, because they are using the same speed without having a direction, without having a friction. Let's say here we have 10 meters per second, and it has 10 meters per second, the other one will be 10 meters per second. The object is turning around from this center with the same speed, but not with the same velocity. Okay, it has different velocities. Why? Because they have different directions. Since the velocity is a vector quantity has to have a direction with the magnitude and the number. So in this case, we have a uniform circular motion, and in the uniform circular motion we have the same speed but different velocities. So I'm going to give you further information about the centripetal acceleration and centripetal force. What is the meaning of the acceleration? First of all, the acceleration is change in velocity. Change in velocity. So if there is the same velocity all the time, we can talk about the acceleration because we have 10 meters per second to the east, and the second motion is going to be 10 meters per second to east. The third one will be the same. So we don't have change in velocity. We have the same velocities, but in this case, we have the same number, the same magnitude, 10 meters per second, but different directions. So because of the different directions, we have different accelerations. So one of the most important things that what is the direction of the acceleration, the direction of the force. Why? Because they are related to each other. You know that when we want to know what is the force is going to be mass times acceleration. It means that if we know the direction of the acceleration, we can drive the direction of the force as well. Okay, because the force and the acceleration is going to be in the same direction. So how can we know the direction of the acceleration? By using these vectors, I mean the velocities, we know that the acceleration is change in velocity over time. So what is the meaning of the change in velocity? It means that final velocity minus the initial one. Okay. So the acceleration is a vector quantity. Again, it has a direction like the velocity, and it depends on the velocities, change in velocities. As you can see, this is the initial vector, the initial velocity, and this is the final velocity. When we want to apply this formula, final velocity minus the initial one, we are going to take, or I can write it like that. Final velocity plus negative initial velocity. Final velocity plus negative initial velocity. It means that we have to draw the final velocity. Then we have to add the negative of the initial velocity. Okay. It means that we have to change the direction of the initial velocity. We will add to the final velocity. Final velocity plus the negative initial velocity. And as you can see, the change in velocity means the acceleration. Acceleration is, look, the direction is looking to downward. It means that the velocity is gonna be like that. Okay. The acceleration is gonna be to the center. This is one of the most important information. Okay. The velocities are changing because of the direction, but when we use the formula, change in velocity gives us the acceleration. So the acceleration's direction is to the center. That's why we call it centripetal acceleration. What is the meaning of that? Central seeking acceleration. Okay, this is very important. Central seeking acceleration. So we have to know the acceleration is looking towards the center, and the force is gonna be looking towards the center. That's why we call them centripetal acceleration and centripetal force. Okay. One more keyword, then we will conduct our experiment in order to understand these keywords better. Okay, what is the meaning of the inertia? Inertia is the tendency of an object to use the same velocity, the same direction all the time. For example, it is about the rejection for changing the velocity and changing the direction. It means that it wants to use the same velocity and the same direction all the time. Example, For example, you are driving a car and then you can see the red light, then suddenly you stopped. Okay, what is going on inside of the car? The body of the car is stopping, but you are moving forward, right? Why? Because you had a speed, you had a velocity, and you wanted to use the same speed and the direction all the time. That's why you are going forward. You don't want to stop. Okay. What about the opposite way? Let's say you are stopping at the red light, then the green light comes out, then you press the gas pedal, you are accelerating, you are moving forward. What about your body? Your body is going backward. So this is the meaning that you were stopping and you wanted to stay at the rest position, so you want to go back by using the inertia. It means that the object is using the same velocity and the same direction all the time. So let's go and conduct our experiment by using these informations. As you can see till here, we learned that the uniform circular motion is that the uniform circular motion inside of a circle there is a moving object and it's using the same speed, not the velocity. And the velocity about the number 10 meters per second is the same, but they don't have the same velocities. They are changing the velocities because of their directions. Okay, and then we jump to the centripetal acceleration and the force, and we know that the vectors, the velocities are vectors and they have directions. So when you use the change in velocity formula, we learned that the acceleration is looking towards the center, and that's why we call it centripetal acceleration and centripetal force. And in this case, let's continue with our okay, let me duplicate it. Okay, in this case, we will have an experiment about circular motion with a garden hose. And in this case, the garden hose will be given to you guys, and I'll give you the balls. And you can use this ball, you can play with it, and we will have a tape in order to fix the garden hose in a good position and try to use the same way, the same conditions all the time. Okay, as you can see, okay, just wait. You will have a ball, then you are going to throw it inside of the circle. Then it goes out. First of all, we will see the demonstration inside of the circle. Inside of the circle, it has the same speed, but different directions. As you can see, it has different velocities because all the time it's looking to another direction. This is the first step. And then we will see when it goes outside of the hose, it will use the same circle or it will use the same velocity at the end of the last movement from the hose. So this is very important point that we need to use the keyword inertia here. Okay, here what is it going on? Okay, you can try it by using your paper. Let me give you the paper. So you will fill these questions and everything, and at the end of the lesson you will give it back, turn it in to me. Okay, what is it going on here? We are throwing the ball, and the ball is going outside of the hose, and it's using the same path. Okay, this is very important. When it goes outside of the hose, at the last velocity and the last direction will be our velocity and the direction right now. So we have two movements, inside of the hose and outside of the hose. Inside of the hose we have the same speed, different velocities, different accelerations and different forces. But outside of the hose, when it goes outside, it will use, you can take the ball, it will use the same velocity right now when it goes outside. When it goes outside, it will use the same velocity and the same direction outside of the holes. As you can see here, the ball enters, okay, it moves, and at the last point, it will go outside with the last velocity. So right now, it's using this path. It's not circular anymore. It will use the last velocity and the last direction. Okay, let's see the questions. Then we will answer some of them. Then it will be the end of the lesson because our lesson is a sample lesson. It's going to be 15 minutes. Let's say compare the speed and the velocity constant or changing. Speed. Inside of the hose, the speed is what? What do you think? Inside of the hose, speed is the same or different? What do you think? Constant or changing? Tell, say it.
Changing.
No, it's speed is the constant because inside of the hose, as our title, uniform circular motion inside of the hose. What about inside of the hose? The velocity. Velocity is changing because the direction is changing. Okay, after the ball leaves the hose, it will use the same velocity and the same direction all the time, so it's going to be constant. And what about the speed? When the velocity is constant, speed is going to be this constant because it's using the same direction, the same magnitude, and the same path, the same unit. So, today we have learned the keywords: uniform circular motion, tangent velocity, which is the outside of the circular motion's velocity, and the centripetal acceleration, centripetal force, and the inertia. These were the keywords. And what is your assignment at the end of the lesson? Your assignment is going to be, you have to prepare an article from your research. You have to make a research. You can Google it. You can find information from internet. Then write the keywords, definitions, and also this paper is going to be your homework. The article and the paper is going to be your homework, and it will be due for the next lesson. So I will see you after 2 days, most probably, for the next lesson. So this is at the end of the lesson.